A septic tank is a key component of the septic system, a small-scale sewage treatment system common in areas with no connection to main sewage pipes provided by local governments or private corporations. Other components, typically mandated and/or restricted by local governments, optionally include pumps, alarms, sand filters, and clarified liquid effluent disposal means such as a septic drain field, ponds, natural stone fiber filter plants or peat moss beds. Septic systems are a type of on-site sewage facility. In North America, approximately 25% of the population relies on septic tanks. This can include suburbs and small towns as well as rural areas. Indianapolis is an example of a large city where many of the city's neighborhoods are still on separate septic systems. In Europe, septic systems are generally limited to rural areas. Since a septic system requires a drainfield that uses a lot of land area, they are not suitable for densely built cities. The term septic refers to the anaerobic bacterial environment that develops in the tank which decomposes or mineralizes the waste discharged into the tank. Septic tanks can be coupled with other on-site wastewater treatment units such as biofilters or aerobic systems involving artificial forced aeration. Periodic preventive maintenance is required to remove the irreducible solids that settle and gradually fill the tank, reducing its efficiency. According to the U.S. Environmental Protection Agency, in the United States it is the homeowner's responsibility to maintain their septic system. Those who disregard the requirement will eventually be faced with extremely costly repairs when solids escape the tank and clog the clarified liquid effluent disposal system. A properly maintained system, on the other hand, can last for decades or possibly even a lifetime. Description: a septic tank generally consists of a tank of between 4,000 and 7,500 liters connected to an inlet wastewater pipe at one end and a septic drain field at the other. In general, these pipe connections are made via a T-pipe, which allows liquid to enter and exit without disturbing any crust on the surface. Today, the design of the tank usually incorporates two chambers, which are separated by means of a dividing wall that has openings located about midway between the floor and roof of the tank. Wastewater enters the first chamber of the tank, allowing solids to settle and scum to float. The settled solids are anaerobically digested, reducing the volume of solids. The liquid component flows through the dividing wall into the second chamber, where further settlement takes place, with the excess liquid then draining in a relatively clear condition from the outlet into the leach field, also referred to as a drain field or seepage field, depending upon locality. A percolation test is required to establish the porosity of the local soil conditions for the drain field design. The remaining impurities are trapped and eliminated in the soil, with the excess water eliminated through percolation into the soil, through evaporation, and by uptake through the root system of plants and eventual transpiration or entering groundwater or surface water. A piping network, often laid in a stone-filled trench, distributes the wastewater throughout the field with multiple drainage holes in the network. The size of the leach field is proportional to the volume of wastewater and inversely proportional to the porosity of the drainage field. The entire septic system can operate by gravity alone or, where topographic considerations require, with inclusion of a lift pump. Certain septic tank designs include siphons or other methods of increasing the volume and velocity of outflow to the drainage field. This helps to load all portions of the drainage pipe more evenly and extends the drainage field life by preventing premature clogging. An Imhoff tank is a two-stage septic system where the sludge is digested in a separate tank. This avoids mixing digested sludge with incoming sewage. Also, some septic tank designs have a second stage where the effluent from the anaerobic first stage is aerated before it drains into the seepage field. Waste that is not decomposed by the anaerobic digestion eventually has to be removed from the septic tank, or else the septic tank fills up and wastewater containing undecomposed material discharges directly to the drainage field. Not only is this detrimental for the environment but, if the sludge overflows the septic tank into the leach field, it may clog the leach field piping or decrease the soil porosity itself, requiring expensive repairs. How often the septic tank has to be emptied depends on the volume of the tank relative to the input of solids, the amount of indigestible solids, and the ambient temperature, as well as usage, system characteristics and the requirements of the relevant authority. Some health authorities require tanks to be emptied at prescribed intervals, while others leave it up to the determination of an inspector. Some systems require pumping every few years or sooner, while others may be able to go 10–20 years between pumpings. An older system with an undersized tank that is being used by a large family will require much more frequent pumping than a new system used by only a few people. Anaerobic decomposition is rapidly restarted when the tank refills. A properly designed and normally operating septic system is odor-free and, besides periodic inspection and pumping of the septic tank, should last for decades with minimal maintenance. A well-designed and maintained concrete, fiberglass, or plastic tank should last about 50 years. Potential problems: like any system, a septic system requires maintenance. Although septic systems generally require less maintenance than others, in contrast to communally connected sewage systems, the maintenance of a septic system is often the responsibility of the resident or property owner. For this reason they are sometimes perceived to require higher maintenance than other systems. Neglected or abused systems can pose the following problems. Excessive dumping of cooking oils and grease can cause the inlet drains to block. Oils and grease are often difficult to degrade and can cause odor problems and difficulties with the periodic emptying. Flushing non-biodegradable items such as cigarette butts and hygiene products such as sanitary napkins, tampons, and cotton bud swabs will rapidly fill or clog a septic tank, so as in other systems, those materials should not be disposed of in that way. As with all drainage systems, the use of garbage disposals for disposal of waste food can cause a rapid overload of the system with solids and early failure. Certain chemicals may damage the components of a septic tank, especially pesticides, herbicides, materials with high concentrations of bleach or caustic soda or any other inorganic materials such as paints or solvents. Certain chemicals can kill the septic bacteria needed for the system to operate. Most notably, even very small quantities of silver nitrate will kill an entire culture. As with communal sewage systems, roots from trees and shrubbery growing above the tank or the drainfield may clog and or rupture them. Playgrounds and storage buildings may cause damage to a tank and the drainage field. In addition, covering the drainage field with an impermeable surface, such as a driveway or parking area, will seriously affect its efficiency and possibly damage the tank and absorption system. The flushing of salted water into the septic system can lead to sodium binding in the drainfield. The clay and fine silt particles bind together and effectively waterproof the leach field, rendering it ineffective. Like communal sewage systems, excessive water entering the system will overload it and cause it to fail. Checking for plumbing leaks and practicing water conservation will help optimize the system's operation. Very high rainfall, rapid snowmelt, and flooding from rivers or the sea can all prevent a drain field from operating, and can cause flow to back up, interfering with the normal operation of the tank. High winter water tables can also result in groundwater flowing back into the septic tank. Over time, biofilms develop on the pipes of the drainage field, which can lead to blockage. Such a failure can be referred to as biomat failure. Septic tanks by themselves are ineffective at removing nitrogen compounds that have potential to cause algal blooms and waterways into which affected water from a septic system finds its way. This can be remedied by using a nitrogen-reducing technology, or by simply ensuring that the leach field is properly sited to prevent direct entry of effluent into bodies of water. Environmental issues. Whilst a properly maintained septic tank poses no more environmental problems than centralized municipal sewage treatment, certain problems could potentially arise from a neglected installation. Some pollutants, especially sulfates, under the anaerobic conditions of septic tanks, are reduced to hydrogen sulfide, a pungent and toxic gas. Likewise, methane, a potent greenhouse gas, is another byproduct. Nitrates and organic nitrogen compounds are reduced to ammonia. Because of the anaerobic conditions, fermentation processes take place, which ultimately generate carbon dioxide and methane. The fermentation processes cause the contents of a septic tank to be anaerobic with a low redox potential, which keeps phosphates in a soluble and, thus, mobilized form. Phosphates discharged from a septic tank into the environment can trigger prolific plant growth including algal blooms, which can also include blooms of potentially toxic cyanobacteria. The soil's capacity to retain phosphorus is usually large enough to cope with a load through a normal residential septic tank. An exception occurs when septic drain fields are located in sandy or coarser soils on property adjoining a water body. Because of limited particle surface area, these soils can become saturated with phosphates. Phosphates will progress beyond the treatment area, posing a threat of eutrophication to surface waters. In areas with high population density, groundwater pollution levels often exceed acceptable limits. Some small towns are facing the costs of building very expensive centralized wastewater treatment systems because of this problem, owing to the high cost of extended collection systems. To slow residential development which might increase the need to construct an expensive centralized sewerage system, building moratoriums and limits on the subdivision of property are often imposed. Ensuring existing septic tanks are functioning properly can also be helpful for a limited time, but becomes less effective as a primary remediation strategy as population density increases. In areas adjacent to water bodies with fish or shellfish intended for human consumption, improperly maintained and failing septic systems contribute to pollution levels that can force harvest restrictions and/or commercial or recreational harvest closures. In Washington State, USA, a shellfish protection district, or clean water district is a geographic service area designated by a county to protect water quality and tideland resources. The district provides a mechanism to generate local funds for water quality services to control non-point sources of pollution, such as septic system maintenance. The district also serves as an educational resource, calling attention to the pollution sources that threaten shellfish growing waters. Trees in the vicinity of a concrete septic tank have the potential to penetrate the tank as the system ages and the concrete begins to develop cracks and small leaks. Tree roots can cause serious flow problems due to plugging and blockage of drain pipes, added to which the trees themselves tend to grow extremely vigorously due to the ready supply of nutrients from the septic system. Regulations. In May 2012 the Environment Agency in the United Kingdom invited property owners with small-scale septic tanks to register them with the organisation so that an exemption certificate might be granted. However, it was likely that a number of users of such systems might find that their system fell outside the tolerances applied in order to claim exemption and so a bespoke permit might be required. It was likely that the requirement to register septic tanks to gain an exemption certificate would be implemented from January 1, 2013. All packaged sewage treatment plants must have the EN 12566-3 certificate to qualify for an exemption certificate. In-tank conversion systems would require a permit from the Environment Agency for discharge direct to a watercourse as these systems are not covered by any of the EN 12566 certifications. See also. References. External links, Homeowner's Guide to Septic Systems, note, this could use some improvement. The following links are general agency department sites covering a whole gamut of related topics. They may very well prove to contain content related specifically to septic tanks, but which would take considerable additional effort to locate. Thus the reader is not provided with relevant information but with an additional searching task. A general Internet search would probably be more useful. U.S. Environmental Protection Agency, Massachusetts Department of Environmental Protection, Rhode Island Department of Environmental Management.